So we're going to be looking at page 12, specifically number 6 and number 9. So number 6 says the population of Powder Springs is growing at a rate of 5% per year. In 2010, the population was 500,000. What would be the predicted current population? So we're going to start by determining whether or not this was an exponential growth or a decay. Well, if it's growing, then we're definitely dealing with an exponential growth. Our initial amount or starting amount is that 500,000, which is also our A. And then our growth decay rate, actually we're dealing with our growth again because it's growing. Rate would be that 5%. Remember, the rate is either usually a decimal or a percentage. So 5% is actually 0.05. And then our growth factor, because it's a growth, we're going to do 1 plus that 5% or 1 plus that 500ths, which would give us 1.05. So that's our growth factor. And then they're asking us to write the function. Well, the function is usually y equals a times b raised to the x. Our a in this case is 500,000. Our b is our growth factor, which is a 1.05. And that's raised to the x power, which represents our time. So then they're asking us, what would be the predicted current population? Well, we're currently in 2020, and they started at 2010. So that means that we're dealing with a 10-year difference. So x is actually equal to 10. Again, because they started in 2010, we're currently in 2020. So our time in this case is 10 years. So we're going to use our function that we just created, which is y equals 500,000 times the 1.05. But now we're going to raise it to the 10th power because we know specifically what our time is. So when we do that, we can go straight calculator. So we're going to put in the 500,000 times the 1 in 500ths. And we're going to raise it to the 10th power. And when we do that, we end up getting 814,447. So because we're dealing with people, we're going to round to the nearest whole number. So now it says, use the equation from the previous question and predict in what year Powder Springs population will first reach 1 million. So this one's a little different because what they're asking for is they're asking us to predict what year. So if we're talking about the year, we're actually talking about the time. So they really want to know what's our x. Well, they gave us our y, which is our 1 million. So we're going to plug in 1 million wherever we see y. So we have 1 million is equal to 500,000 times that 1.05. And it's going to be raised to our x. But again, that's what they want us to find, which is our time. So if you have a calculator, a TI-36X Pro calculator, then you'll be able to find your answer. If not, it's okay. We're just going to stick with this as our answer for right now. But if you did have a TI-36X Pro calculator, what you would do is you just have to hit second and sign for our numSolve. And then we're going to put in that 1 million on the left-hand side, and it's equal to that 500,000 on the right-hand side. And then we're simply going to multiply it by our 1.05, and it's raised to our x, raised to the power of x. And when we hit enter 3 times, we'll get our answer. So our answer turns out to be 14.2. So let's double check. So that means if I were to plug in 14 wherever we see x, that should give me approximately 1 million. So let's go ahead and try that. So I'm going to plug in that 500,000 times that 1.05, and now I'm going to raise it to the 14th power just to see if it gives me my answer of 1 million. And what we'll notice is it gets really close to 1 million, but it's not exactly 1 million. So 14 years doesn't actually make it that 1 million, but let's see if we were to put it to 15 years, then we'd realize that that would give us our 1 million. So although it said 14.2 is over the 14 years, so we would actually have an answer of 15 years. And that answer, if we added 15 years to the 2010 that we started with, the specific year would be 2025. So now we're going to move to problem number 9. Problem number 9, it says a super deadly strain of bacteria is causing the zombie population to double every 2 days. Currently, there are 25 zombies. After how many days will there be 5,600 zombies? They said careful with this one. So this one's going to be a little different from the one that we just did previously. So let's start with this. It's asking what's our initial amount. Well, we're starting with 25 zombies. So our initial is actually 25. They didn't give us a specific rate. They didn't give us a percentage or a decimal. So technically, we're going to jump to whether or not we're dealing with a growth or decay factor. Well, we know that we're dealing with a growth because it says that it's doubling. So that's the key thing. If something is doubling or tripling, then it's actually going to be a growth. So if something's doubling, that means that my growth factor is actually 2. Doubling meaning 2. So our function that represents this situation is actually y equals our initial amount, which is 25, times my growth factor, which is 2, raised to the x. So now they're asking us, after how many days will there be 25,600 zombies? Well, we already have the function, but again, this is similar to the previous problem where they're asking us how many days. So we're dealing with our time again. They're asking us to find x. So they're giving us our y, which is 25,600. So they're giving us our y, and that's equal to the other part of our formula, which is 25 times 2 raised to the x. So again, they're asking us to find the time or the amount of days. So again, if you don't have your TI-36X Pro, we would simply just take this answer for right now. But if you did, what we would do is just go straight to our num-solve. So second in sign, clear out anything that you had in there. On the left-hand side, what we would do was put our 25,600 and then put our 25 times 2 raised to our x power. And then we simply just have to press enter 3 times. And so we would get an answer of x is equal to 10. So now let's think about this answer, because they said something earlier in the problem that we have to kind of focus in on. So if x is equal to 10, that would be if it was doubling each day. But right now what it told us is that it's going to double every 2 days. So this 10 represents each day. But if it's doubling every 2 days, that means we're literally going to have to multiply our answer by 2. And so our answer is actually 20 and not 10, because it's taking 2 days for it to double rather than the 1. Okay, so again, our answer would be 20. All right, next part. It says, if the current population of our planet is 5 billion people, after how many days will there be no humans left? So again, they're asking us for how many days. So they're dealing with our time. So we have to make sure we're looking for our x. They did give us our y, which was our 5 billion. And that's equal to the other part of our function, which is 25 times 2 raised to the x. So again, we're solving for x. So if you were able to use your calculator, we would simply put that in the calculator by using second sign for num-solve, clear out whatever you have in there. So we would have 5 billion on the left, and then we would have 25 times 2. Sorry, making sure you can see. So we would have the 5 billion on the left, the 25 times 2 raised to the x on the right. And when we press enter 3 times, we would end up getting that x is equal to 27.5. So if we were to round that, we'd get x is equal to 28. But again, we have to remember that it's taking 2 days for it to double. So this would represent every day, but we're taking 2 days. So we're simply going to take our answer and multiply it by 2. So our answer is actually, it's going to take 56 days for there to be no zombies.